Toy-Con rocket plunger is a device that is used to launch model rockets from a safe distance. It is made up of several components to allow easy storage and use, which I will showcase later. First, let's take a look at the Toy-Con rocket plunger. The Toy-Con rocket plunger is a simple mechanism. It has a plunger which moves up and down within its main body. However, to launch rockets with it, it needs to be connected to a battery so it can send an electrical signal and ignite the rocket, which is what these white cables are for. The Nintendo Switch console sits in the front of the plunger box so that the screen can easily be seen and used. A cardboard overlay is placed on top to create a graphical user interface. There are three components to the user interface: the status lights, main screen, and launch animation. The status lights dictate whether it is safe to initiate the countdown sequence. They are colored by green, yellow, and red cellophane taped on the back. When the green ready light is lit, you can double tap the screen to initiate the launch countdown sequence. The countdown will count from 10 down to 0. Once the timer reaches 0, the plunger can be pushed down, launching the rocket into the air. This will activate the cooling phase, which tells you that the plunger has just been used. After a few seconds, the green light will light up, telling the user not to launch the rocket. To see how the Toy-Con rocket plunger works, we have to take a look inside the main body. In the center of the body is a small casing for a 6-volt battery. The middle segment of the plunger fits into it and moves up and down. Its vertical movement is restricted by a peg which slots through the battery case and the middle segment of the plunger. On top of the middle piece, an upper piece of the plunger is connected and also held together with another peg. Inside this piece is the right Joy-Con. I'll get to that in a moment. Once all put together, the plunger is ready to be used and moves like this. The reason why the right Joy-Con is inserted into the upper segment of the plunger is because that piece stops moving last. Because the bottom segment touches the battery and stops moving first, the Joy-Con is placed at the bottom of the upper plunger piece, which when pressed all the way down will see the cardboard below using the IR motion camera. This is what activates the animation on the Switch's display. The last thing that hasn't been explained is how the Toy-Con rocket plunger connects to the rocket and makes it launch. Since there is a battery at the base of the plunger, the bottom of the plunger has two ends of copper cables stuck to it. These are positioned so that they come into contact with the positive and negative terminals of the battery and hence send an electrical signal to the rocket launching it. You may have noticed that I used aluminium foil to increase the surface area of the connection point. Although this is a very cheap option, it isn't very reliable as aluminium isn't a good conductor. But for the purpose of this project, it works well enough to launch a rocket. There is also a small cardboard spring to prevent the plunger from falling onto the battery and sending an electrical signal at the wrong time and launching the rocket. Now that you know how the Toy-Con works, let's take a look at the programming in the Toy-Con Garage. The node setup for this Toy-Con is quite messy, but very simple. The programming is separated into two parts, the countdown and the animation. First, let's look at the countdown timer. It is made up of a series of light nodes to display digits, similar to a digital clock's display. This countdown is activated by a large touch input node which covers all of the lights. To activate the timer, the screen must be double tapped to prevent accidental activations of the countdown. This is controlled by counter nodes, which are on the side here. When the screen is touched, it sends an input to the counter node, which has a maximum value of 2. To ensure that the screen is tapped twice, the extendable light node is used with a bullseye node. Once the value of 2 is reached, the extendable light node will be full and the bullseye node will detect it and send an input to the counter node at the top of the workspace to begin the countdown. The numbers are outputted by having each number connected to their respective counter node. For example, this second node here will display the number 9, so all of the light nodes that form to create the number 9 are turned on for 1 second. Then, all the nodes to create a number 8 are displayed for the next second, and so forth. The countdown is also connected to the 3 status lights on the left of the countdown. Once the countdown begins, the green lights turn off. Then, when the timer finishes and after the plunger has been pressed, the red light activates and stays on for a few seconds. Afterwards, the yellow light lights up and stays on for under a minute, after which the screen can be tapped once, or the right button on the left Joy-Con can be pressed, which will clear the lights and activate the green light. The other component of this Toy-Con Garage workspace is the rocket blast-off animation. This is completely separate to the countdown in the sense that it will not play if the countdown reaches 0. Instead, as mentioned earlier, the IR motion camera is what activates the animation. The IR camera is set to only see things from a very close distance, so it doesn't see the cardboard beneath it when it is not pushed down, and only when it gets very close to it. So when the plunger is pushed down, the IR camera sees the upper segment of the lower plunger piece, and then sends an output to a counter node which begins the animation. The animation is set up similar to the countdown timer in the sense that every 0.2 seconds or so, the next frame of the animation plays by lighting up a group of light nodes at once for that fraction of time. That pretty much sums up all of the programming, so now that you've learnt about the Toy-Con rocket plunger, let's see it in action. Thank you for watching, and I hope you've learned something new or have been inspired to create your own unique Toy-Con. If you would like to see some of my other Toy-Con creations, you can view my playlist with all of the Toy-Con I have created. If you enjoyed the video, please leave a like, comment your thoughts, and subscribe if you'd like to see more Labo related videos in the future. Again, thank you for watching, and I hope to see you around.